Okay, so here's the key for the practice test that I said I'd have up. So here it is. Get my pin. Okay, so evaluating 4 to the 5 halves power. I'm going to go through these kind of fast. So the 2 on the bottom indicates a square root. So we're going to do the square root of 4 and then take that quantity to the 5th power. Remember that 5 can go on the inside, but you'll just be working with bigger numbers if you do that. So the square root of 4 is a 2, and then I put the 5th power back on there. 2 to the 5th power is 2 times 2, which is 4, 16, 32. Okay, so that's the first part. Okay, next part, negative 64 to the 2/3. So same thing, the bottom part, that bottom 3 is a third root. So third root of negative 64. And then we're going to take that whole quantity and square it. So remember, you can take the odd root of a negative because there are 3 negatives that multiply to be 64, and I believe it's 4. So the cube root of negative 64 is a negative 4 because negative 4 times negative 4 is positive 16. Positive 16 times negative 4 is negative 64. And then you still got that squared on the outside. So you get the squared. Now this is the quantity of negative 4 squared, this whole thing. So negative 4 squared is a positive 16. Alrighty, next one, 243 to the negative 1/5 power. So negative exponent property tells us that the negative brings it to the bottom, so it's going to be 1 over 1/5 power. I'll write it out. So 243 to the 1/5 power. And remember, 1/5 power is a 5th root of 20. Whoops, I forgot a 3 on there. 243. 243, 1 over that. 243, I think, is 3 to the 5th power. Yeah, 243. So the 5th root of 243 is 1 over 3. Alrighty. Next one. And those disappeared for some reason. Alright, let's try this. I have to shrink it down a little so that I don't have to keep. Okay. Sorry about this, but just want to make sure this doesn't like mess up. Okay, so you got the 4th power of, this is one term because there's no plus or minuses in here. So you are allowed to multiply the 4 in here. So that's going to be 2 to the 4/3 times 5 to the 4 halves. Okay. Uh, 2 to the 4/3. So remember, the bottom is a root, right? So this 3 is telling that you're looking for 3 of a kind, and this 4 is telling you got 4 2s. So if you got 4 2s and you need 3 of them to take out, and if you want to, you can do the third root of 2 to the 4th power. But I'm going to go ahead and show you with just the root. So since I know that I need 3 of a kind, and I got 4 of a kind, I can take a 2 out. So it's 2 times, and then what's still left over is 2. So I took 3 of them, so I got 1 left over. 2 to the 1/3. 2 times 2 to the 1/3. 5 to the 4 halves is 4 divided by 2 is 2, so 5 squared is 25. Okay, now we got 2 times 25. We got 3 pieces here, but multiplication, you can multiply in any order. So I'm going to multiply the 2 times the 25 first. 2 times 25 is a 50. And then I got 2 to the 1/3 still. And that's it. Okay. All right, so this one, we have the same root, cube root. So what we're going to go ahead and do is put everything underneath the same cube root. There are other ways to do these, but this is probably the most efficient. So since I'm putting everything under the same root, I can go ahead and combine these together. There's a 27 here. There's no numbers over here, so it's just going to be a 27. We got an x cubed here. There's no x's here, so it's just staying an x cubed. I got y squared, which is y times y. Y to the 4th power, which is 4 y's, y, and then 4 plus another 2 are 6 y's altogether. So y to the 6, and then z to the 9th. There's a z here, no z here, so it's just z to the 9th right there. So cubed means I'm trying to look for 3 of a kind. 27 is 3 times 3 times 3, so I can bring out a 3. These match up, cube and cube root, so the x comes out. 6 is a multiple of 3, so I actually have two groups of y's, so it's going to be y squared. 9 is also a multiple of 3, so I got three groups of z, so z to the third, and that's everything that comes out, so that's it. Now, if there was any stuff left over, say you had like an extra, I don't know, extra x hanging out on the side, then you would put cube root of x to account for that. But there's nothing left over. We took everything out. All right, so let's move down. Next ones. Okay, so this is the composition stuff, or the, sorry, the adding, subtracting, and multiplying of two functions. So what I do want to see here on your test is I want two sets of parentheses minus another function. One function minus another function, so f of x is x squared plus 3x. And g of x is a 2x plus 1. All right, so in front of this one, remember we got to drop the parentheses before we can start combining like terms. Please do not multiply this out. This is not a multiplication, it is a subtraction. So to take them out of the parentheses, we need to put ones there and distribute. So that's going to be just an x squared. 1 times 3x is a 3x again. 1 times 2x is a negative 2x, and negative 1 times 1 is a negative 1, or minus 1. Now that we have them out of the parentheses, now we can combine like terms. X squared is just x squared. 3x minus 2x is a positive x plus x and a minus 1. And that's it on there. Okay. So it says find domain. Since there are no even roots and there's nothing dividing by, then our domain is basically just all real numbers. So double line through that. That's part of your answer too. Okay. So same thing over here. What you want to do is g of x plus f of x. All right, so your g of x function is 2x plus 1. So we're going to put a 2x plus 1 here. Your f of x function is x squared plus 3x. So x squared plus a 3x. Okay, same thing here. Nice thing about this one though, there's no sign changes because you're distributing positive ones. So everything just stays the same. So you got a 2x plus a 1 plus, distribute the 1 here, you'll get an x squared plus a 3x. Next thing is combining like terms. Start with the highest exponent, which is a squared. No other squares, so it's going to be x squared. 2x and the 3x are like terms. You can put those together. That's going to be a positive 5x. And this 1, there's nothing else to combine with that, so it's just a plus 1. That is your g of x plus your f of x function. Once again, domain is all real numbers, basically because nothing will mess it up if we plug it in for your x values. No even roots and no dividing, so domain is all real numbers. Okay, and last one, f of x times g of x. So this times another thing. So f of x is x squared plus 3x. G of x is a 2x plus 1. Now at this point, since we are multiplying and you guys have all kinds of ways you guys multiply, you can use any method you want. You can use a distributive property. You can use the box method. You can use FOIL here because they're both binomials. But any method that you use, you should end up with 4 terms on the next step. So that, you should get a 2x to the third. So I'm going to go ahead and distribute. So x squared times 2x is a 2x to the third. X squared times 1 is a x squared again, plus x squared. 3x times 2x is a 6x squared. And 3x times 1 is a 3x. So I distributed the x squared to both of those, and then I distributed 3x to both of those. All right, so combine like terms now. We got a 2x cubed, x squared, these are like terms, put them together. 1x squared plus 6x squared is a 7x squared, and plus a 3x. And that's it for that one. Once again, there are no even roots, so we don't got to worry about negatives. There is nothing being divided, so we don't got to worry about dividing by 0. So your domain, once again, is all real numbers. Alrighty. Okay, so we're on number 9. F of x over g of x. So f of x is x squared plus 3x, so x squared plus 3x over 2x plus 1. So that's going to be x squared plus, I already forgot what I was saying. X squared plus 3x is your f of x squared plus 3x. And I think it was 2x plus 1, but let me double check. Yep, 2x plus 1. Bottom is 2x plus 1. Now at this point, we're not going to simplify this anymore. So we just leave it like this when you guys have the dividing. So that is f of x over g of x. But there is a domain restriction here. Since we have dividing, we know this entire bottom part is not supposed to be 0. So what we do is off to the side, you put 2x plus 1 should not be 0. We don't want this quantity on the bottom to be a 0. So now you solve it out. So minus 1, you get 2x should not be a negative 1 then. And divide by 2, so you get x, therefore cannot be negative 1 half. So your domain is all real numbers, except x cannot be negative 1 half. And that is your domain. All right, so number 10. Ow, sorry, my hand's starting to get kind of weird. So number 10 is f of g of x. Or sorry, g of f of x. So since the g function is on the outside, that's the first function you're going to write. So you're going to put 2, that's a 2x plus 1 function. But remember, you put a blank spot everywhere you see an x. So 2 blank spot plus 1, because that used to be 2x plus 1. Now inside of the blank spot, you're going to put your f of x function, which was your x squared plus a 3x. All right, so now it's just a matter of simplifying. So I'm going to distribute the 2. So 2 times x squared is a 2x squared. 2 times 3x is a 6x. And then plus 1. Be very careful. Do not distribute this 2 all the way out to the 1. The 1 is not inside of the group. So, and that's it. And I told you guys you don't have to find the domains on the compositions. Okay, so it's just 6 through 9. I need the domains there. Okay, so number 11, write the equation for the inverse of the relation. So first step to finding inverses, switch your x and y. So this is going to be x equals 3/4 of y minus 7. Okay, next step is to solve for y. First step is to add 7, so you're going to get x plus 7 equals 3 over 4y. Now at this point, if you guys are pretty good with the whole multiplying by the reciprocal thing, you can do that, or you can think of this as 3 divided by 4 times y, in which case you do 2 steps. I'm going to go ahead and just do the, well, actually, you know what, most of you guys do the, hold on. Oh no, did I do something weird? Oh, nope, still there. Yay. There it is. Okay, so with this, I'm going to go ahead and do it like how most of you guys do, where you think of it as 3 divided by 4 times y. So if you're dividing by 4, the opposite of dividing by 4 is multiplying by 4. So we're going to multiply both sides by a 4. 4x plus 14, 20, 28 equals, and then these 4's cancel, you get left with a 3 times y. Now you can divide by 3. Divide this whole side by 3. So 3 does not go into either of those. So, so we just leave it alone. So this is going to be y equals, actually, you know what? Either way is fine with me. I'd be okay if you guys left it either way. So this is 4x plus 28 over 3, or another way you could write this is 4/3 x plus 28 over 3. So I'll accept either one of those as your answer. This form technically is a little bit nicer because you're used to seeing that whenever we're working with linear equations. But like I said, I would accept this part too. All right. Next one, find the inverse of this function. So a little bit of work between here, but eventually you're going to get x equals y plus 4, and that was weird. Okay. Um, Hold on. Ew, those ended up weird spots. Okay, so y plus 4 to the 1/2 power minus 9. Okay, so basically what I did is I turned this into y, and then I switched the x and the y. Okay, so now my goal is to get the y by itself. So the first thing I want to get rid of is that minus 9. So to get rid of the minus 9, you're going to add 9 to both sides. So this will end up being x plus 9. The 9 is going to cancel on this side. So y plus 4 to the 1/2 power. Okay, so main thing to remember here is that the 1/2 power is the same thing as a square root. So if it helps you out, you can write this side as a square root, which most of you guys like doing, so I'll go ahead and show that way. So this will be the square root of y plus 4. So get rid of square root, you square both sides. So we're going to square this side and square this side. Okay, x plus 9 squared, you cannot distribute the exponent because there are two terms here. You're only allowed to do the properties of exponents when there's one term. So you actually have to multiply this out. X plus 9 times another x plus 9. You will end up with x squared plus 18x plus 81. All right, and then squares and square roots are opposite operations, so those undo each other. So you get a y plus a 4. Last step, get rid of the 4, so we're going to minus 4 minus 4. You get x squared plus 18x. That's 77 equals y. Since this started off as f of x, we got to switch it back to that form. I'm going to go ahead and move the flip the equation over. So the y is f inverse of x equals x squared plus 18x plus 77. Alrighty, and that's that one. So let's see, what number are we on? That's number 13. Okay, so number 13 are the inverses of each other, so we have to do the f of g of x and g of f of x. So there's two things you need to do here. So I'm going to draw a line down the middle. So first one, we're going to do g of f of x. Other side, we've got to show f of g of x. We got to show um, these are inverses by showing that after you do these inverses, you should end up with x in the end. All right, so g of f of x, that's going to be, gotta write kind of small here, not that much space. 1/2, and then a blank spot, minus 1/3. Okay, and then the 6x plus 2 over 3 goes inside of here. Okay, the f of g of x part, that's going to be 6 blank spot plus 2 over 3. That's this f part, and then we're going to put the g in, so that's going to be 1/2 x minus 1/3. Alrighty, now when you're multiplying fractions, you got to remember you do the top times the top and the bottom times the bottom. This is all one fraction inside of here. So we're going to multiply the 1 multiplied by the 6x plus 2, but 1 times anything is the same thing again. So we're going to end up with a 6x plus 2 on the top again. And then bottom times bottom, 2 times the 3 is just a 6. And you do minus 1/3. Okay, so it's 6x divided by 6 and 2 divided by 6. So 6x divided by 6 will, why is it doing that? 6x divided by 6 will just be x. And 2 over 6 reduces down to 1/3. So plus 1/3. And you guys subtract 1/3 also. 1/3 minus 1/3 is a 0, so you'll just get an x. All right, so that's nice on that side because that's what we wanted. All right, so on the other side, we got 6 times 1/2, so half of 6 is a 3x, so that's going to end up being a 3x. 6 times negative 1/3, so that's the same thing as 6 divided by 3, which is a minus 2. And then you also have a plus 2 up there. And then you got a 3 on the bottom. That's not a negative, it's an equal sign. Okay, and then the -2 and +2, those end up being opposites operations. So is this times 3 and dividing by 3? So those are all gone. You just have your x left over there. And it is verified. Verified. All right, there you go. Okay, I think we're nearing the end here. Okay, so graph these two functions. So this one, since there is a shift, we do need to, let's see here. So the shift, so inside with the x is going to be the opposite. This is my horizontal shift. So our horizontal shift is left 4. Vertical shift is up 3. Okay, so left 4, up 3. We want to make our new, whoops, f of x table over here. So we accounted for the 4 and the 3, right? That's our shift. So all I got to write is this part. So square root of x. This is our non-shifted table. So x and y. So pick nice and neat numbers for the square root of x. Perfect squares, 9, whoops, 9. Next perfect square down would be a 4. Next perfect square down would be a 1, and then 0. We can't go past that because we'll get square roots of negatives. We don't want any complex numbers on this thing. So square root of 9 is a 3, square root of 4 is a 2, square root of 1 is a 1, square root of 0 is a 0. Okay, now what we're going to do is we're going to make a shifted table. So x and y. So left 4, that means from all of your x values, you're going to be subtracting 4. Up 3, all your y values, you're going to be adding 3 on. So -4 from a 9, you're going to get a 5. 4 minus 4 is a 0. 1 minus 4 is a -3. 0 minus 4 is a -4. Okay, now we're going to add 3 to our y's. So 3 plus 3 is 6. 3 plus 2 is 5. 3 plus 1 is 4. And 0 plus 3 is 3. So now you're just going to plot all those points and make your graph. Let's see here. All right, so our x's are from -4 to 5. And okay, it's hard for me to draw straight lines with this thing. So I apologize for the, oh, this horrid graph. Okay, so -4, 1, 2, 3, 4. +5, 1, 2, 3, 4, 5. And then up to 6. 1, 2, 3, 4, 5, 6. We got points at -4, 3. Okay, -4, 3, -4 and 4, -4 and 4, 0, 5, and 5, 6. 3, oops, 1, 2, 3, 4, 5, and then 6. Okay, and remember these graphs go like this. Okay, hopefully yours is a little bit nicer than mine. I don't have any like straight edges or anything I can use on here. All right. Wow, 23 minutes in, huh? Okay, so cube root graphs. Let's do this. So this is going to be right 3, and +2 is going to go up 2. So once again, you're going to make your non-shifted graph over here. So I accounted for the 3 and the 2. So it's going to be just the cube root of x. So for this one, make sure you pick nice and neat cube roots. So first cube root, probably a nice one would be an 8, because the cube root of 8 is a 2. Next one would be a 1, because the cube root of 1 is a 1. Cube root of a 0 is a 0. Now with this one, since it's an odd, I can put negatives here. And the nice thing about making my non-shifted graph is that I'll have a mirror image here. Okay, and then the cube root of a -1 is a -1. The cube root of a -8 is a -2. So let's shift this thing over. So x and y. That's going to be right 3, so +3, up 2, so +2. So you're going to add 3 to all your x values. So that's going to be 11. 1 plus 3 is a 4. 0 plus 3 is a 3. Negative 1 plus 3 is a 2. Negative 8 plus 3 is a negative 5. Okay, going to add 2 onto here. So 4, 3, 2, 1, and 0. Um, since this is kind of running long on time, I'm not going to show the graph. But the graph basically should look like half a parabola going this way somehow, and draw another half parabola going that way. That's what a cube root should look like. And then, yeah, that's the general shape of that graph. 18. Okay, so quite a bit left. Trying to get this done faster so that I can get this up for you guys tonight. Um, so minus 10. Um, I believe most of you guys liked switching these fractional exponents into actual radicals. So I'm going to go ahead and do that. So it's the square root of x, square root of x to the fifth power. I'll put it on the inside. Minus 10. You know what? I'm going to show you guys how to do this without doing that. Warning, I erased. Yeah, that was kind of a late warning, but too bad. Okay, so minus 10 plus 10 plus 10. These cancel. That's going to be x to the 5 halves equals 22 plus 10 is a 32. Okay, so to get rid of 5 halves, what you guys would do is actually do the 2/5 exponent to the 2/5 on both sides. The reason why we do that is because 5 times 2 is 10, 2 times 5 is 10, 10 over 10 is a 1, so you get your x. Okay, so now with this side, now you can start thinking about the roots. Now we got the fifth root of 32 to the second power. Now 32, I believe, is 2 to the fifth power, hopefully. 2 to the fifth power is 32. So the fifth root of 32, so now you guys can do the root thing. So the fifth root of 32, and then we're going to square it. Okay, so this ends up nice and neat. Fifth root of 32 is actually a 2, and then you square it, and then you get x equals 4. Now, I'm okay if you guys do that part actually in your head. If you actually know the fifth root, this means fifth root of 32 is a 2, so you can rewrite this down to here. Okay. All right, next one, let's subtract 1 minus 1. 1's are 0 equivalent, so you get x plus 8 to the 1/4 power equals negative 1. So what we're going to do now is we're going to do the fourth power. Oh, hold on, that's an equal sign. So we're going to do fourth power each side. And this is a fourth power. So you'll get x plus 8 equals positive 1, and minus 8 minus 8, you'll get x equals negative 7. All right, so what I forgot to show over here was our checking step. So if I check this, I plug a 4 in here. So if this is a 4, the square root of 4 is a 2, 2 to the fifth power is 32, minus 10 is 22, so that checks out. Okay, so over here, negative 7, let's do that up here, plug it in, make sure it works. I actually shouldn't have boxed it until I made sure it worked. So negative 7 plus 8 is a 1, so 1/4 power, fourth root of 1 is a 1, plus 1 is a 2, so we're actually going to get 2 equals 0. That is not true. This is not your answer. So this is no solution. But remember to plug in, make sure that it works out. If it doesn't work, make sure you show your check step. Okay, so next one. By the way, it was this part right here that messed everything up because a fourth root is an even root. There's no way to do an even root of this and get a negative out. So yeah, that should have given you a red flag that you're going to end up with no solution. So minus 11, minus 11, you're going to get the cube root of 7x minus 9 equals 3. This one should end up nice and neat because you can take a cube root and get a positive out. So this looks okay. So we're going to cube this side. We're going to cube this side. Cubes and cube roots. So 7x minus 9 equals 3 times 3 is 9 times 3 is 27. So plus 9 plus 9. 9's are gone. 7x equals 36. Divide by 7. It's going to be x equals 36 divided by 7. Doesn't go in, so just 36 over 7. Okay, just a quick check, but it should, whoa, everything should work out okay though. If you put a 36 over 7 inside of here, 7 times 36 over 7 is 36. Minus 9 is a 27. Cube root of 27 is a 3. Plus 14 is a 14, so it works out. All right, last two. I think we did these ones in class. We did number 20 in class, so I'm not going to show that over again. Well, I'll show that over again, but I'm not going to show the check step just because this is running really high on time. We did the check step. It was with the decimals where we plugged it in, so everybody should have notes on that. Since this one we have two square roots, this side, so don't write this. I'll write this in red to try to show you not to write this. If you do this right now, it messes up. Or it doesn't mess up, but it makes it really difficult because you have two terms here, so you're not allowed to distribute this squared. If you did that, you would have to do with all of this stuff in each of these and actually multiply it out, which would be a big headache. So we're not going to do that. Bye bye, go away, red stuff. Okay, so what we're going to do is we're going to move this to this side. The way we're going to do that, oh no, I don't know why it does that when I do that. I also don't know why I talk to myself while I make these. Okay, I'll just erase. So I'm going to do plus 3 square root of x plus 3 square root of x on both sides. These ones will be gone. You get square root of 4x plus 15 equals 3 root x. Now that I have one term here and one term here, now I can square both sides. Okay, squares and square roots, 4x plus 15. Make sure you square both of these parts. So 3 squared is a 9. Squares and square roots cancel, so you'll get 9x. Now it's just a simple linear equation, minus 4x minus 4x. 4x are gone. 15 equals 5x. So x must be a 3. All right. Plug it in, it'll work out. 4 times 3 is 12, plus 15 is 27, square root of 27. So you're going to get a square root of 27 over here. And then that's minus 3 root of 3. But 27 is 3 times 3 times 3. So you can actually take out double 3. So 3 root 3 minus 3 root 3 is a 0. So that checks out. Okay. All right, so number 20, we did this one in class, so if you already know how to do this one, then feel free to turn off the YouTube. But if not, go ahead and follow the little pin thingy. Okay, so we're going to square these first. Square these first. Okay, squares cancel, you get a 2x plus a 1 equals, square this, you should get a 4x. Whoa, that was weird. Again. Alright, so we get a 4x squared. That's going to be a 6, negative 12x, and positive 9. Okay, so we need one side to be a 0, so I'm going to subtract 2x and subtract a 1. So minus 2x and minus a 1 equals 0. So we get a 4x squared minus a 14x plus 8. Okay, so looking at this thing, I can use a bunch of different ways to solve it, but the first thing I'm noticing is that I have a common factor here. Common factor here is 2, so I can take out a 2. I get a 2x squared minus a 7x plus a 4 equals 0. Now, the reason why I did that is because now that I know 2 times this whole thing, I'm solving, so I can divide by 2 and get those to go away. The nice thing here is that 0 divided by 2 is still a 0, and now I have smaller numbers I can work with. Minus 7x plus 4. So this is not factorable. So since I can't factor it, and this doesn't look like a nice, neat one for the um, completing the square, so let's go ahead and use the quadratic formula. X equals negative b, so that's going to be a positive 7 plus or minus the square root of negative 7 squared, which is a 49, minus 4ac, so that's 416 minus 32, all over 2a, so 2 times 2, which is a 4. Okay, so that's going to be 7 plus or minus square root of, let's see here, 17 over 4. So x is equal to 7 plus the square root of 17 over 4. And x equals 7 minus the square root of 17 over 4. In class, we went over the check step. It turns out that this one does not work out. This one actually does. Okay, and remember to do the check step, go ahead and turn these into decimal equivalents, and then take the decimals and plug them back in the originals to check your work. Okay, and that is your practice test, and I hope this helps out. Remember, you got your test tomorrow, so good luck studying. Okay, bye-bye.